Hi, and welcome to today's iTree Web Replay. Today's presentation will be on iTree View, and our presenter will be Mike Binkley of the Davey Institute, located in Kent, Ohio.
This is really actually kind of nice for me to go after ECO because it's a good view is a good contrast of between field data collection like ECO, pretty intensive, and kind of what I kind of term as a remote sensing canopy assessment. Hopefully everybody can see the slide up, and don't forget the scroll bars at the bottom and right on your screens if you need to move it around. So before I get into the View program, I wanted to set the stage a bit with the actual data. And I think there's a little bit of trepidation with satellite-based data, and I think as long as everybody understands kind of where it's coming from and the costs involved with various types of data, I think it frames View a little bit better. So again, we're talking with View and Canopy here from the iTree application suite. We've got two remote sensing tools. Canopy tends to be basically a statistical estimation via photo interpretation, and we're actually using Google Maps there, which Dave will show in a little bit. View is using Landsat data as the first case data, which has been worked into a product called the NLCD, and I'll talk about that here in a minute. Just really quickly, in terms of the arrow on the left side, if you can frame kind of the three tools all the way down to a very high-end, really accurate hyperspectral UTC analysis, you're talking very low cost for the satellite data that View uses, very little time involved with it, but at the same time the resolution is low too, because you are getting data generated from a sensor platform that's 500 miles up in the air. You get down to hyperspectral overflights and additional GIS analysis to check it, etc., and the labor and time involved, you're getting in more costs. So keep in mind, View is kind of the door opener for people to kind of begin pursuing investigation into their urban forest benefits, and also for those areas of the country that just simply don't have the data or the money to generate the data. Just real brief plug for the Landsat program. The last Landsat satellite's been up there since '03. Funding's always in jeopardy. If you ever get a chance to put a positive plug-in for it, please do so. That's where these data for View are coming from, and they may be low resolution, and they may be seen as out of date at times, but again, there's nothing else out there, especially not free, and also nationwide. Again, this thing's up 440 miles up in the air. It does cross over the same spot on the Earth every 16 days, which is great because we can constantly be comparing images. The Multi-Resolution Land Characteristics Consortium, or the MRLC, as sometimes you'll hear the NLCD, or National Land Cover Data, referred to. This is the group that put the NLCD together. Right up until about a month ago, we've had NLCD 2001 data. And yes, that is 10 years old. Similar to the way the census runs in 10-year rounds, the NLCD data is a horrendous undertaking. I've talked to some of the guys behind it, and they're spending 5+ years mapping and analyzing the entire country. It's not something that's automatically generated and thrown up, within just a few days. They actually are taking air photos, the Landsat data, GIS data, etc., and region by region, almost climate regions, so to speak, they're going through the country and putting these data together. Again, 30 meter by 30 meter on the ground. So we're talking large areas, regions, larger cities. But then again, you certainly can use it for homeowners association, because you're not going to get your homeowners or condos association to do a hyperspectral overflight anytime soon. So the NLCD data is typically three products: the land cover data, which you can see here with the different classifications, an impervious surface, which is just a percentage, 0 to 100%, and a canopy percentage, same thing, 0 to 100%. Again, they did divide up the country into mapping zones, but as Dave Nowak and his crew out of Syracuse has shown, there is, known underestimation for both tree cover and impervious cover. And within each of these zones, they've actually come up with the adjustment factors, which allow you to kind of get an idea of the degree to which the canopy cover, for example, is off. Nationally, it's underestimated by about 10%. Some areas out west, it's pretty high. Again, it's not perfect data, but it is contiguous across the lower 48, much of Hawaii, and the populated areas of Alaska, and it's free. So with that being said, I'm going to switch over to View here. To launch View, the first thing that is brought up, hopefully everybody's seeing a small window that has 3 bits of imagery in it, and this window is entitled the Browse for NLCD Imagery. Now these image data sources, you can go right to the MRLC website. We have instructions, very simple instructions, right in View. It's actually this button right here, the NLCD Download Help. Anybody can go to the website, zoom into their area, their city, their county, and bring it down within, I did it again this morning, within about 5 minutes from the local city that I'm in. It's free. It's fairly easy to work with. Lately, within the last month, they've actually brought out an update, and you can maybe actually see here, I've got land cover 2006 data and impervious cover for 2006 loaded in. They have not updated tree canopy yet. I'm not sure if they're planning to or not, but again, being what the data are, this is a free source, and it's fairly easy to work with. In this case, this first screen in View, it allows you to browse for the imagery that you've downloaded from the MRLC site. You simply load it up via these browse buttons, very regular Windows application, very straightforward. I'm kind of cheating here because I've already browsed to the folder before, so it came up very quickly. Again, Dave Nowak and his crew out of Syracuse has provided state default pollution values. He can talk a little bit more about those at the end. These are the values for computing the amount of pollution removed by tree canopy and dollar amounts related to those amounts, etc. With version 4 of View, we've set up basically a very simple GIS clipping function, because what happens with the NLCD imagery is it comes down as a square. You cannot download like a specific city boundary or a university boundary, etc. It is a seamless coverage for the entire country, so you download a square which contains your area. I've added this function right here at the bottom which allows you to manually define an area of interest on this unclipped imagery. I'm going to take you there right now, and hopefully this is visible on your screens as well. It's a rather complicated process, but we've tried to make it as simple as possible. On the left, you have a Google view with the red square there, which is actually the footprint of the NLCD imagery that you are working with. You can zoom in to a specific area of your city using the simple Google tools at the top that we've created. I'm going to actually carve out a subset of the NLCD data. I'm going to try to do this relatively quickly before I get the hook and then pulled off stage here. This is a small section of the city I happen to live in. And you can see what I've done there is transferred it over onto the NLCD imagery, and I'm going to run a simple clipping operation, which is not perfect, but it does a fairly decent job of going through and removing the land cover data and tree cover data and impervious cover data around that area. You can see there are tools in here which allow you to actually clean up a bit if you need to. Let's switch over to land cover. In this case, the clipping function wasn't the greatest, so I'm going to just go ahead and clean up. I save out these images because they're going to be altered images, and it prompts me to save. I have to save each of the three because we're ultimately working with each one. 1 second there. So I'm going to actually work with this smaller area just to prove that it is possible, because this is one of the most important updates we've done with version 4 is it allows you to get in there and start working with specific bounded areas rather than the entire gigantic square of data that you would bring down from the MRLC site. So View is set up, this is the main screen. View is set up with 4 windows, with a simple map control bar, toolbar down at the bottom. Each of the 4 windows is tied together, so when you zoom or pan, they all move together. The NLCD data, tree canopy, and impervious cover are all statistically tallied up, in this case on this general tab on the right, giving you the total tree canopy in acres, impervious, etc., the aggregated land cover classes, developed, forest, wetlands, etc. Within specific land cover classes, we break it down further as far as we can with the NLCD land cover data. So in this case, my area has a medium intensity developed land cover class of 192 total acres, which is about 14.5% of the entire area. And within that developed medium intensity land cover class, we have about 2.5% tree canopy and a good 62.4% of impervious cover. That's what IC and TC are here. This is repeated for the other land cover kind of aggregate classes, even down to agriculture. In addition, we've added some additional tools, though, kind of mapping tools with version 4. One is called Google Find. I'm going to go ahead and click right there, which hopefully is my house. Yes. What it does is it launches kind of a mini web browser, lets you see that actual pixel right there in red, where it would lay on top of the Google Air Photos, because Google has nice air photos, satellite air photos. Gives you the tree canopy, the impervious cover, your coordinates, gives me the nearest address it can find, and it lets me pan around and use, of course, the regular Google Map tools. In addition to that, being able to find the pixels, because after all, it is kind of hard to understand what you're looking at here in terms of these square blobs of riot color, we've introduced Google View, which lets you kind of take a handful of the pixels and throw them right up on top of the Google Maps as well. So in this case, that's the highway I mentioned over there. There is a pond in the apartment complex near me that comes up that way. And again, keep in mind, these are 30 meter by 30 meter pixels, so it's not going to give you a complete fine resolution on the ground. You can certainly see these with the satellite layer or the air photos. There's a forested tract next to the apartment complex. It's built up there, the pond, etc. In terms of general map tools, that's the Nickel Tour. In terms of what you can do with View,
you can snap that to the lower right too, can't you?
Yeah, definitely. And you can keep that up. What David just mentioned, we've made it so it's dockable. Since we have 4 screens going on here, we can kind of throw it up on the bottom right there so that you can kind of compare what you're looking at and undock it as well at will. And basically, anytime you need to know where you're at, those Google tools that's what they're there for. If you trust me though, if you stare at the land cover data long enough, you'll start understanding what you're looking at. In terms of what you can do with Google, with iTree View, the 2 main things are getting the benefits in terms of, say, pollution removal and carbon storage, carbon sequestration. I'm going to run one real quick here, hopefully quickly. In this case, for the aggregated land cover categories, using those default state averages in terms of the amount of, in this case, ozone, pounds per acre per year of tree canopy that are being removed, I can go through and calculate and show on the map and also tally up exactly what's going to go on here. So that's it. That's the whirlwind tour of View. As Scott tells me, I've gone long again, so I'm going to stop talking now.
Thanks for joining us for the iTree View video replay. For more information on iTree, please visit www.itreetools.org.